Welcome back to the AWS Machine Learning Associate review and walkthrough. This time we're going to go on SageMaker, which is not SageMaker AI, but SageMaker. But before we get started, hit the like button, subscribe, share this with anyone else you know taking the AWS Machine Learning Associate exam. So, SageMaker, the complete machine learning platform. Machine learning promises transformational business outcomes, but the complexity of implementing machine learning workflows often overwhelms organizations. Data scientists spend countless hours wrestling with infrastructure instead of focusing on model development. DevOps teams struggle to scale training workloads and manage model deployments. Business leaders can watch projects languish in proof of concept stages, never reaching production impact. SageMaker can transform the landscape by providing a unified platform that handles the entire machine learning lifecycle. Rather than cobbling together disparate tools and managing complex infrastructure, teams can focus on what matters most, building models that drive business value. The machine learning lifecycle. So, a traditional machine learning implementation requires orchestrating multiple complex processes. Data preparation involves extracting, transforming, and engineering features from raw data sets. Model training demands substantial compute resources and careful hyperparameter optimization. Evaluation requires rigorous testing to ensure model performance meets business requirements. Deployment introduces new challenges around scalability, latency, and monitoring. The cycle continues with model retraining as new data becomes available and business requirements evolve. Each phase traditionally requires different tools, technologies, and expertise. Data engineers used one set of tools for preparation, data scientists employed different platforms for training, and DevOps teams relied on separate systems for deployment and monitoring. This fragmentation creates bottlenecks, knowledge gaps, and integration challenges that slow time value. So, SageMaker eliminates these silos by providing integrated capabilities across the entire machine learning lifecycle. It enables seamless workflows from data prep through production deployment and ongoing model management. The architectural foundation. So, SageMaker's architecture reflects AWS's cloud-native approach to scalability and integration. At its core, the platform leverages familiar AWS services while adding machine learning-specific capabilities that abstract away infrastructure completely. S3 serves as the central data repo, storing raw data sets, processing training data, and trained model artifacts. This centralized storage enables easy data sharing between different phases of the machine learning lifecycle while providing the durability and scalability that enterprise workloads demand. Elastic Container Registry, or ECR, hosts Docker images containing training algorithms and inference code. The containerized approach provides flexibility so teams can use pre-built algorithm containers for common use cases or create custom containers for specialized requirements. Training infrastructure dynamically provisions EC2s optimized for machine learning workloads. And these instances can automatically scale based on training requirements, then terminate when jobs complete, ensuring cost efficiency. The training process pulls from S3, executes the containerized algorithms, and saves the resulting model artifacts back to S3. Inference infrastructure provides similar elasticity for model deployment. You have real-time endpoints that serve individual predictions with low latency, while batch transform jobs process large data sets efficiently. The same containerized approach ensures consistency between training and inference environments. And notebook instances. These offer familiar Jupyter environments for data exploration and model development, while integrating seamlessly with the broader SageMaker ecosystem. These managed environments eliminate the overhead of maintaining development infrastructure while providing the flexibility data scientists expect. Data flow strategies. File mode versus pipe mode. So, understanding how SageMaker handles data during training is crucial for optimizing performance and costs. The platform offers two distinct approaches that address different use case requirements. File mode. This represents the traditional approach where SageMaker downloads the complete data set from S3 to local storage on training instances before beginning the training process. This mode works well for smaller to medium-sized data sets and algorithms that require random access to training data. The approach is straightforward and compatible with most training algorithms, making it the default choice for many scenarios. Then there's pipe mode. So pipe mode takes a streaming approach, feeding data directly from S3 to training algorithms as needed. This eliminates the download phase, allowing training to begin immediately and using less local storage. Pipe mode particularly benefits scenarios with large data sets where downloading everything upfront would be time consuming and storage intensive. The choice between modes depends on your specific requirements. Consider file mode for exploratory work in smaller data sets or algorithms that need to access data randomly. Choose pipe mode for production training on large data sets where start time and storage efficiency matter more than data access flexibility. Okay, so let's go and get a little hands-on in here. All right, so you got to understand SageMaker requires experiencing the workflow firsthand. So the platform's console-based approach makes it accessible while providing powerful capabilities for your machine learning projects. So in the taskbar, we'll go to SageMaker. See, there's a difference between SageMaker and SageMaker AI. All right. So we go to accesses in the console. All right, you see the dashboard showcasing. All right, SageMaker and capabilities. So we'll start by the fundamentals. And let's see, domains. Let's create a domain. All right, so you have a quick setup and you have a manual setup, right? So the quick setup is recommended. This is for exploration. So see the domain name, execution role, so we can create and use a new service role. We have a domain service role, right? This is for domain level actions by the SageMaker Studio. You can customize some encryption, user role policies. This is a little more advanced, meaning you're going to use specific types of resources. So you basically attach the role rather than using the default roles up here, right? Or in conjunction. Yeah, there's with the custom encryption key, we can create a new key here. We're not going to do that though. Choose the role policy. We went over that. Okay, service roles for data analytics, for provisioning roles, managing access, query execution. Select the VPC. That would be our default subnets from this. Let's go for 1A and C. All right. And so Gen AI resources. Well, onboarding. Okay. All right. So let's create the domain. But basically, you set up this development environment, give it the description, give it the IAM roles, provision the VPCs, and you wait for it to go into service. This is going to take some time, right? SageMaker is going to integrate with S3, like we saw earlier, to make data access seamless. And the platform will handle authentication and optimization automatically, letting you focus on the data understanding rather than the access mechanics. It contained a wildcard. That's interesting. Okay, so let's go into Unified Studio. All right, so from here, you have all sorts of agents you can complete, right? So you can train built-in algorithms with optimized implementations of machine learning algorithms that eliminate the need to implement algorithms from scratch. So these have built-in algorithms that are optimized for performance and scale. So they're ideal for production use. So let's see. Let's try to create a notebook, select that project. Oh boy. All right, and create the project. And this notebook. We don't need a project profile. We'll use this one to analyze data, build machine learning, generative AI models. Yeah, so this will work with the basic stuff. All right, and description. All right, so here we go. Project name, test notebook, description. We didn't have anything. Domain, we just created that. Capabilities, all right. So storage will be in S3, the S3 location. It's right here. So the retention for the CloudWatch logs. Ooh, 731 days. Let's try for 1 day. All right, project repo auto sync. So we'll have it default, so it doesn't matter. Yeah, that's fine. Because if you have it auto sync, this will create some difficulty. So your lake house, so you make a glue database, go on with this one. And then from here, we click create project. We're not going to do that just because it's going to create more complexity. All right, but this is a very basic way to get this. And from here, well, let's create it. Let's go for it. All right, so it's deploying the tool, deploying the lakehouse database. All right. All right, so it'll make the training instances, it'll pull algorithms from the ECR, it'll download trainings from your S3, it'll execute the training processes and save the resulting model back to the S3. And you can monitor model progress through the console or the notebook outputs. All right. And so you can do this by deploying, you're gonna have to use some Python. That'll be a lot more significant in your machine learning expertise and training, right? So you'll have to do stuff to your endpoint for any algorithms you need. And you can create persistent or terminating endpoints that can help with predictions and solve low latency. And you can test the endpoint immediately, or you can wait. But this is going to take time. So we'll go to view projects and see this. We're going to tear this down, so no worries. If you're following along, you don't have to create this unless you want to start going along with this. All right. And then within this, you can also do batch processing scenarios if you want to generate predictions for large data sets. Again, you're going to use your Python. And the batch training is going to be more cost effective for processing large volumes of data that don't require real-time responses. All right, so we're going to let this, I'm going to tear this down later. We're going to move forward. All right, so you saw some of this as far as the trainings that are available. This will help you get good for being machine learning, but we just did a basic preview. All right, let's go into cost. Okay, costs. Okay, so SageMaker, it has flexible pricing, and the model aligns costs with actual usage, but understanding the different cost components helps to optimize expenses while maintaining performance. So notebook instances charge hourly based on instance type, regardless of utilization. So you stop notebook instances when not actively developing to avoid unnecessary charges. For teams with irregular usage patterns, consider using SageMaker Studio instead of persistent notebook instances. Training jobs charge based on instance type, number of instances, and training duration. Optimize costs by choosing appropriate instance types for your workload characteristics. So CPU intensive algorithms may benefit from compute optimized instances, while deep learning workloads often require GPU instances, meaning more costs. You can also use spot instances for fault tolerant training workloads to achieve significant cost savings. And then you have model hosting. These charges are applied continuously for real-time endpoints based on instance type and count. Right-size your infrastructure based on your expected traffic patterns, and consider like a multi-mode model endpoints for scenarios with multiple models and moderate traffic volumes. Also, use auto-scaling to handle traffic variations efficiently. And remember, batch transform jobs charge similarly to training jobs, but terminate automatically after processing completes. They're often more cost-effective than persistent endpoints for batch prediction scenarios. Data transfer costs apply when moving large volumes of data between regions or to and from the internet. So keep training data, training instances, and model endpoints in the same region to minimize the charges. Okay. So how do you integrate within ecosystem? So SageMaker's power multiplies through integration with other AWS services, creating machine learning solutions that address real-world requirements. So Athena can enable SQL or SQL-based data exploration and data preparation directly against data stored in S3. It makes the data accessible to team members who prefer SQL over Python, and results can feed directly into SageMaker training jobs. You have stuff like EMR, which will provide distributed processing capabilities for massive data sets that require pre-processing before training. EMR can handle complex ETL, extract, transform, load operations, and feature engineering at scale, outputting prepared data to S3 for SageMaker consumption. Amazon Redshift offers data warehouse capabilities, and this is for structured data analysis and feature engineering. SageMaker can query Redshift directly or work with data exported to S3. AWS Lambda enables serverless automation around machine learning workflows, and it can trigger training jobs when new data arrives, sending notifications when models complete training or implementing custom inference logic for specialized use cases. CloudWatch also provides comprehensive monitoring and alerting for all SageMaker resources, enabling operational excellence and proactive issue resolution. And finally, AWS IAM provides the fine-grained access control, ensuring that team members and applications have the appropriate permissions while maintaining security boundaries around sensitive data and models, which we saw when we were setting up that notebook. So the path forward. So SageMaker represents a fundamental shift in how organizations approach machine learning implementation. By abstracting away infrastructure complexity while preserving flexibility and control, the platform enables teams to focus on business value rather than technical overhead. Success with SageMaker requires understanding its architectural patterns and choosing appropriate approaches for specific use cases. Start with built-in algorithms for common scenarios, then explore custom containers as requirements become more specialized. Use notebook instances for development and experimentation, but implement proper CI/CD practices for production deployments. The platform's comprehensive capabilities support organizations at every stage of machine learning maturity, from initial experimentation through enterprise scale production deployments. As your machine learning capabilities grow, SageMaker's advanced features like automatic model tuning, multimodal endpoints, and edge development will provide pathways for continued sophistication. So understand SageMaker's fundamentals, its architecture, data handling models, training and deployment patterns, and integration capabilities. This provides the foundation for leveraging AWS's complete machine learning ecosystem effectively. That concludes this introduction to SageMaker. Before you go, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. Until next time, have a good day.